This package, remember, is about the weird equations. Okay, the name of this equation is rational equation, and this is rational because the variable is located in the numerator and denominator, but basically the important thing is in the denominator, no? Entonces now you need to be careful you solve this equation because you need to check in restrictions. And copy 8. We did number 7 now. 8, 9, and 10 we did. Minus 4 divided by m squared minus 4m equal m minus 4 over m squared minus 3m. Entonces I want to recall, if I copy in one corner of the piece of paper, the step we should do to solve this equation. The first is factor. Factor who? Factor denominator. You can factor numerator, but it's not important. Because the idea is find the least common denominator. Entonces es obvio que es. In this example, we have 3 trinomial. I open 6 parentheses. I put a variable because I try to find the combination that open the door of the factorization. I suppose it's 2 and 1. 2 and 1. Negative. Let me know if you don't understand something, no? In this case, 2, 2. 9, 2, 4. A negative off. And here is 2 and 1 again. Oh, no, this is is exactly the same for the first repetition, the same stupid thing. Negative. All right, the second step. You finish the factorization, find the LCD. Let me copy here, LCD. LCD is, remember the rule, take every factors, but if you have factor repeated, you take majority, no? And then, entonces, how many, what is the factor that we have in our problem? We have n minus 2, and we have n minus 1. Okay, entonces, n minus 1, I take it only one time, n minus 1. You see, because not necessarily you take this, you have this, but you take only one. But be careful with the n minus 2. How many times you believe that you take n minus 2? 1 time, or 2 times, or 3 times, or 4 times? No idea?
1.
1. Another idea?
2.
2. Look at that. You take majority in one expression. We have 3 expressions. 1, 2, 3. We have here only 1 n minus 2. And n minus 2 here. It's obvious because it's repeated. However, you have double here, n minus 2. So the majority, you can write, you want to see more clear, n minus 2, because they are twin brother, square. It's obvious you take n minus 2. You can write like that, a square, or whatever you want, by n minus 1, n minus 2, n minus 2. Either way, make you consider it better for you. Do you understand que tú?
Yep.
Okay, cool.
Professor, one question. This n minus 2 and n minus 1, did it come with the problem, or do you use factor?
No, I did factorization. Yeah.
Oh, okay.
The first thing I did was factorization. Any trinomial, bam. Okay, at the beginning I did that, no? Now we focusing now in the selection of the factor that participate inside the least common denominator, no? Okay, entonces basically is the LCD is okay, n minus 1, n minus 2, n minus 2. Number 3 step is multiply by LCD. But this idea is classical. This idea is magic. When you multiply one equation que contain fraction, numerical or non-numerical, like this, by the least common denominator magically happen, the fraction disappears. Fraction anymore. But you need to be careful. I forgot the restrictions. Okay. Entonces, step 3 is restriction. Restriction is no 1, no 2. Is the guy doing 0, the least common denominator. You take 1 by 1, in this case, n minus 2 is repeated, no? But it's okay. It's only 1. This is the important value that you need to be careful. When you finish to solving this equation, you compare our new equations. The story is clear. You transform my complicated equation in one relatively easy equation. But this new equation is no equivalent 100% because we have restriction. Okay, so now how you solve the problem? No complicate. You continue working, keep going. And the last moment you compare with the restriction. They are coincidence, you discard. No coincidence, no problem. Okay, so now the easy part is simplification. You cancel out n minus 2, n minus 2, n minus 1, n minus 1, and stay alive. N plus 4, que is the expression in the numerator, the first fraction, multiplication by n minus 2. Minus, this minus is this minus 4. 4 stay, of course. Now, when you simplify, you have n minus 2, n minus 2, n minus 2, n minus 2. They stay only n minus 1. Equal, I am here in the equation. Okay, so in the equation, who is cancelled? N minus 1 cancelled. N minus 2 stay. N minus 4 and n minus. Everyone following so far?
Yes.
Okay.
Yes.
New multiplication. In this case, you multiply binomial. Is the classical way of FOIL. Is m squared minus 2m m minus a. Wow, I did the multiplication. Easy. Now here no FOIL because this is monomial and distributive problem. Is negative 4m plus 4. The right hand side is FOIL. Okay, this is m squared m minus 4 and positive. Okay, we combine lighter m squared, no lighter, but minus 2 4 and minus 4. Oh, positive 4 and negative 4 is cancelled, 0. Stay alive, minus 2m minus 4 gets the result subtraction 8 and 4, no? And negative a and positive fraction or opposite sign, and you put a sign always of the bigger number negative, that is minus 4. The right hand side we have m squared minus 6m. Not bad. So you believe, wow, a quadratic equation. No, actually no. And the reason is no, because this and this cancel out. And stay alive only minus 2m. Okay, I propose 6 to the left, and try to condense your grouping the m in the left. In the right-hand side of the equation, stay the numerical part. Okay, it's 8 positive, bring down plus 4. Okay, so now we condense it here. 6 minus 2 is 4, no? M equal to 12. Divided by 4 both sides is 3. We compare with the restriction, no problema, no coincidence. The restriction, the bad guy is 1 and 2. So I suppose que 3 is good. See? Okay, es 3 or negative 3? It's 3. Is this option. Any question? Super confusing or no? I forgot the steps. Number 4 step was multiply. It's a classic. By who? Multiply. Multiply who? The equation. The entire equation by the LCD. By LCD. And the step 5 is algebra. We did FOIL, we did distributive, we did combined term. And actually you solve it inside this linear equation or quadratic equation, depending on the problem. Any question? Everything is clear? May I erase the board? Continue to another example? Yes or no?
Yes.
Yes.
Okay. Number 9. Number 9 is 7 over n plus 4 minus 6 over n minus 4 equal minus 56 m squared minus 16. Come on, guys, help me. I'm lost. What should I do? Step 1. What is the step 1? I don't remember. Factor. Very well. Emily. Okay, so in this case, the only expression that we can do the factorization is the last one. M, or plus or minus, because it's the differences of the square. Boom. Now, what is the next step? I don't remember. After. It's common denominator. Cool. LCD. Who help me? What is the LCD? What factor? I see that we have to factor only m plus 4 and n minus 4. And you take only 1 time, 2 times, I don't know. That part I never understand very well. You take 2 times, 1 time, 3 times, 4 times. Okay, remember the rule. The rule say, the rule is clear. You take every factor. You omit one factor, is no good. No omission. So now you take n plus 4, but only one expression. Either way, the way this guy or this guy, but you pick only one. And likewise, n minus 4. Correct? N minus 4. Okay. Now, immediately I found LCD, you copy the restriction. The restriction is m no 4 and m no negative 4. This is illegal value. And you multiply, n plus 4, n minus 4, multiply 1 by 1 by the LCD. Okay, because you multiply by only one to say affect. And only to doesn't affect my equation, you should apply everything by the LCD. Now we cancel out M plus 4, stay 7, and M minus 4. Minus, it's minus. Okay, here we cancel out M minus 4, stay 6, 9, M plus 4. Equal. Wow, everything is cancelled in the last. M plus 4, M minus 4, and stay only negative 50. That is my easy equation. So you magically transforming the complicated equation, nobody understands very well, in one elementary equation. The rest is algebra. 7m distributed. 7m minus 28 minus 6m minus 24 equal minus 50. And we combine 7 and 6 is 1m. And 28, 28 plus 24 because it's negative both. 52 minus 52 is equal minus 56. Therefore, my m is equal minus 56 plus 52 and negative 4. Wow, and negative 4 is coincident with one restriction. Therefore, we have no solution in this problem. We did before, no? Yeah, we did before. Carajo. We did before, yes. Excellent here, no solution. Now the answer is no solution. You write here in English. Or symbolic way, it look like a 0 and 1 stick, indicate empty set. The interpretation, this equation have no solution. This equation, the solution set is empty, no solution. Cool? This is no frequently happen, but happen. And you need to be aware that when you're solving equations, you have three possibilities. The standard equation is when you have one solution or two. Another equation have no solution like this. Another equation have infinity solution, que is all real number. Okay, let's move on to the last equation, que is 6 over m plus 5 equal, no? Equal 1 minus 1 over m minus 5. Well, in this case, not necessary factorization because the expression involved m plus 5 and m minus 5 are prime. Nice, I like that. Therefore, LCD is the combination both. M plus 5 and m minus 5. And the restrictions associated with that problem is m no 5 and m no negative 5. Now multiplication by LCD, m plus 5, m minus 5. But everything, guys, and included this one, m plus 5, m minus 5. And last one is m plus 5 and m minus 5. Okay. So you cancel out this and this. Stay 6 parenthesis m minus 5. Multiply this time 1. You know 1 is invisible 5. So stay m plus 5 m minus 5. Minus because who is cancelled? It's cancelled m minus 5 and I stay 1 is invisible m plus 5. Okay, this is my new equation. Okay, distributed 6m minus 30. Oh, the multiplication, this is easy. You can apply FOIL, pero no. Well, yeah, you can. But much better, in my opinion, is using the formula of the difference of a square, but backward. And normally, difference of a square is a square minus b squared is equal to a plus b times a minus b. This is a shortcut to do fast. So now when you see you have two factors and they are conjugate. Conjugate means one is positive and one is negative and the same number. Si es 3 and 2, no, pero si es 5, 5 o 2, 2, es obvio. Entonces es m squared minus 25. I confront this. Multiply m times m and 5 times 5 and negative in between. Okay, if you want, I can prove. Look, let me prove quickly. This is piece okay. Suppose I don't realize, I never see that. Okay, no problem. You foil m times m squared. N times negative 5 is negative 5m. And positive 5m is 5m. And positive 5 and negative 5 is negative 25. It always happens in this kind of problem. Without part cancel and stay m squared minus. Exactly like that. I did quickly because I know this is a special case. This is m squared minus 25 minus m minus 5. Entonces look like, this equation look like quadratic equation. Quadratic equation for solving, I need to express it in standard. What means standard? Standard is when you move everything to the one side, another side is 0, and you organize the equation in descending order of the degree, degree 2, degree 1, degree 0. Okay, let me try.
Professor, why m minus 5? Why no m minus, I mean plus 5?
In what case? Here.
At the end.
At the end. Well, is this negative affect minus m?
Oh, I see. Okay.
Yeah. Okay, entonces the focus. We identify, wow, this equation that we get now is not linear, it's quadratic. Degree 2. So I try to put in a standard. Well, okay. First of all, if you want, you put m squared, bring down minus m, que is this guy. And why not 25 and 5 together is 30, minus 30, right? You move to the other side, minus 6m and plus 30. Because this 30 is negative, and move to the right-hand side. Okay. And here we have nothing, it's 0. This is the idea. That's 0 is equal m squared minus 7, no? 7m, negative 1 and negative 6. And fortunately, I say fortunately because it's easier, no? Entonces cancel out.
Professor, that's supposed to be minus 6m. Oh, no. I'm sorry.
No? No. You let me know see I make a mistake, no? So now finally, let me, I feel more comfortable. See, I interchange this. Look, m squared minus 7m equals 0. And we factorization. Remember, this is zero factor property. We need to express this in different factors, and the greatest common factor obviously is m. We factor out m minus 7. Apply the zero factor property when you have several factors, when you have a collection of the factors, equals 0. Take one by one, factor 1 equals 0, factor 2 equals 0, and you solving separately each factor, okay? In this specific problem, first factor is m equals 0, and the second is m equals 7. And this is my potential solution. Okay, immediately I need to verify the restriction. Oh, no. The restriction is 5 and negative 5, not good, no. So now S07 is valid, like the option. Boom. Cool. Okay, guys, of course, you have to practice this equation. I know it's a little bit hard in the online. And also I record again in the review. Okay. Any question? Do you follow me? Let me try next page. I suppose it's another thing. Let me see. I did. Okay, cool. Yeah, no more equation. Too much. Now let's move on to the exponent. This is important. It's important that you need to know how we manipulate with the exponent. And we have exponent fraction, wow, and exponent negative and positive. Okay, let me explain in detail. When you have exponent fraction, suppose hypothetically, you have, for example, 4 numerical example. No. I try to explain the idea behind it. And after we go directly to the problem. Suppose we have 4, I raise 4 raised to the one exponent is, I suppose, is 3 over 2. What means this fraction? To understand this, you can, it's a fraction exponent, if you want to see more clear, you convert in radical notation. What means radical notation? Well, using root, like that, this symbol, no? This is root. You put a number, of course, get 4, but 3 and 2, where is located? Well, one possibility is the denominator, get 2, represent the index of the root. So actually, this is a square root. Okay, you know, a square root, the frequently style is that this 2 is invisible. Everyone know when you put this symbol radical and no specification the index is because it's a square root. And the 3 you put here gets exponent or if you want, you doesn't matter because the order is not important. Okay, fraction contain numerator and denominator. Denominator represent the index of the root. Index of the root. And numerator is the power. We have power in the top, index in the bar. How we compute it? Easy. Square root 4 is 2. And 2 cubed is 8, que es 2 times 2 times 2. Got it? Clear? Clear or no? You see?
Yes, that's clear.
Now I want to complicate your life with the negative exponent. Suppose 4. Entonces, again, I put the same value, is negative 3/2. But what mean to be negative exponent? Negative exponent is reciprocal. But it's reciprocal. It's 1 over raised to the 3/2 positive. Immediately you see negative exponent, you flip it down. No, not necessarily down, depending, no? Si the expression is in the top, you put in the bottom. Pero si the expression que contain negative exponent is in the bottom, you put it in the top. Let's flip it. Reciprocal is the technical name. Reciprocal. Reciprocal. Okay, now I know when to say we focus in the computation of this part I did before. 8 and the answer is 1 over 8. Flip it. Okay, clear, right? Let's move on to the example. Remember, fraction exponent, negative exponent. And I explain another property, but in your moment, no now. Okay, suppose this example. Example 11 say minus parentheses 36 over 49 raised to the 1/2. Wow, what the hell? Well, it's easy. It's a negative. Okay, this negative is totally outside. Be careful with the negative sign. See, negative sign is inside is completely different. Si es outside. This outside means that this negative represents in my mind like a negative one. You keep it. It's a negative one. You keep it. I don't like to put this, but in my mind, working like a negative. Keep it. And you put a square root because the index is 2, 36 over 49, and the power of 1. Okay. Fraction and 2 invisible. 2 is invisible, and the index of the root. And 1 power is invisible because to the 1 power is invisible. Okay, now ready. We apply this property. When you have a fraction inside the root, you can separate numerator and denominator. This is super important property. Help me to simplification the fractions inside the rank. And you can build separately. Square root of 36 is 6 and square root 49 is 7. Boom. This is my answer. My answer is minus 6 over 7. Like the B option. Like the B option. So let me explain. Let me take advantage of this moment. I suppose everyone understands very well everything, right? So far? Yes or no? It's important. The negative is confusing and tricky. The negative is confusing and tricky. Okay, for example, so you have negative, like in this example, and you have a square root 36. The answer is negative 6. Because you compute square root 36 as 6, and this you ignore temporarily, because you suppose that when it's outside, represent like a negative 1 factor. However, very, very different, totally different idea happen if the negative is inside. If the negative is inside, is no real solution. Okay, it's imaginary or complex, but you see after in the chapter 5 slide. Let me explain why it's not real. Because the idea behind the square root is I need to find one number and multiply by itself, same number, give me the number inside the radical. Suppose que I select negative 6 because I believe. No, because negative times negative is positive. I need negative. Now, of course, positive 6 doesn't work. It's tiny guy. Entonces, mechanically, I never negative basic is exactly I need. So when you see a square root, yeah, inside the square root, you have a negative number. Automatically, you're right. No solution. No real solution. The solution living, yeah, we have solution, but no real. Real and the famous or real line. The solution is not in this line. It's in another dimension. 6 doesn't work. Negative 6 doesn't work. I prove here. However, that I try to explain the different options we can find when you have a negative outside the radical, negative inside the radical. And a different situation happen if the index of the root is not even, it's odd index. Suppose this example. Suppose minus square root minus 27 and square root cubic root. So I want to discuss the possibility in which the number inside the radical is negative, but the index is odd index. When I say odd, maybe it's 3, maybe it's 5, maybe it's 7. When it's even, in this case, it was even, it was 2, but the same situation happens, yes, 4, 6, 8 is even number. Yeah, automatic, as you see, for example, 4 root of negative 36, no real solution. No real solution. However, when the index is odd, pay attention, pay attention. Let me solve this first. Oh, the answer is negative 3. Why negative 3? Because the idea behind this cubic root is a number that you need to find one number by 3 times, same repetition, minus 3, minus 3, minus 3, time. Minus 3 and minus 3 is 9 positive, and 9 positive, and minus 3 is minus 27. It's exactly the number inside we have. Okay. Entonces, exists is real. Okay, it's real. This is important. When the index is odd number, it doesn't matter que it's positive or negative. The number inside the radical, we have real solution. Real solution. So the only picky root is the even exponent, but the odd no. And thus in this case similar, right? Except we have another extra negative outside. Okay. Entonces this is negative. You interpret this like a negative 1. And the answer of this I did before is negative 3. And negative 1 and negative 3 is positive 2. Okay. Keep in mind, it's important. It's, confusing. In the problem, sometimes to confuse you, put the negative inside, put the negative outside, and copy different root, cubic root, 4 root, 5th root. Wow, you need to be aware for that situation. And positive and negative. Now let's do in 12. 12 is parenthesis 16 over 81 raised to the negative 1/2. Negative exponent and fraction exponent. What should I do? Well, there are many ways. However, my recommendation is solving first the negative exponent. So you change the negative exponent to positive exponent when you flip the fraction. 81 over 60. Boom. Done. Okay, I solving the negative exponent, get reciprocal. So reciprocal means the expression or the number and the numerator go to the denominator, and the expression or number and the denominator go to the numerator. Switching, flip it. Now you convert to the radical so you want to see more clear. It's a square root. The index is 2 and the power is 1. And why not you separate 2 pieces? And the square root 81 is 9. And the square root 16 is 4. And this is my answer. Checking. I will for IC option. You follow me? Easy, eh? Or no?
So if it's negative, you flip it?
Yes. This is the interpretation of the negative. The interpretation of the negative exponent is reciprocal. And reciprocal is flipped. So the mechanism find the reciprocal is flipped. Okay, 13 now. 13 is 9 raised to the negative 5 over 2. No parentheses. Okay, no parentheses because it's no fraction. So 9 is 9. Fraction. Okay, therefore, what should I do? Negative exponent one more time. How we convert to the positive exponent? Reciprocal. And you copy
1 over 9. Oh.
Exactly. You copy 1 over something. It's 1 because the interpretation of the original is 9 over 1, no? 1 is invisible. In this case was more clear. Can you flip it because you are doing this interchange? But we are doing this interchange. Look at that. Wow. And when you flip it, of course, the new answer is now positive exponent. Okay, now I don't understand very well that part, but the professor explained me that this is square root 9 because this 2 is the index of the hypothetical root square and raised to the fifth power. Okay, and the square root 9 I know is 3, so say 1 over 3 to the fifth power. So you put 3 to the fifth power. And the calculator, you multiply 3 times 3 times 3 times 3 times 3, 5 times. 3 to the fifth power, I did my calculator now, is 243. 240 is the answer. Cool? You understand well?
Yes.
Now 14. 14 is minus 8 over 125 raised to the negative 2/3. Wow. Too many negative. Negative in the exponent, negative in the base, the exponential. So I don't know how we can start, no? We start always for the conversion, negative exponent to positive exponent, always. So it's easy. Look at that. Negative 125 or 8 raised to the third positive. Change negative exponent to positive exponent to flip it, this fraction. And this fraction original negative, of course I keep the negative, no? Because when you flip it, the negative stays. Now, to see more clear, to understand much better, you transform this in radical notation. Actually, it's cubic root. This 3 is this 3. Inside the root, we have 125. And you raise to the second power. I prefer doing outside. Now we focusing in the root first, que es the most complicated part. And finally, you square, que es easy. As you square, entonces big number, entonces more complicated root. So you are doing the complicated part first. Don't mix it together. So now, why not? I can separate the fraction. So you have cubic root minus 125. So you assign this negative in the top part. Either way, in the top or in the bottom. Doesn't matter. So this negative is in the middle. You can suppose it's here or here. Or no, both, no? Only one. So I assume it's in the top. I don't know why. My brain is much better, more clear. Now, cubic root 8. Okay, now a squared. The transformation to the root. And now cubic root negative number is real. Remember, the only guy gets not real is a square root or 4 root or 6 root. So when the index is even and you have inside negative number, yes, it's completely out the real number. But in this case, yes, it's negative 5. It's a negative 5 because negative 5 multiplied by negative 5 multiplied by negative 5, of course, is negative 100. And cubic root a is 2, and you square. U square is like a minus 5, a squared, and 2 squared. This is 25 and 4. And positive, of course. 25 over 4. 25 over 4. 5 over 4. 5 over 4. There you go. This guy. It's too long. There's no big deal. It's super easy, eh? Do one more. Do one more. Wow. Okay. This is now parenthesis 9 over 5 raised to the negative 3 half. 25. One more time, we have negative exponent. The magic is when you flip it, get the reciprocal, my exponent change negative to 1. Now you convert to see more clear in radical notation. Denominator is 2. That means that this root is a square. And that's all we have in the square root. Don't need to specification this two. Default you know que esto. 25 over 9, and finally we raise to the that 3. And the fraction, to say I separate square root 25 and square root 9 cubic. Classical. Separate numerator and denominator and the root. And the square root 25 5, the square root 9 3. Now we have 5 cubic and 3 cubic. 5 cubic is 125 because it's 5 times 5 is 25. So this is equivalent in my mind. Times 5, no? Times 5 is 25, and 25 times 5 is 5. And likewise here, this is 3 times 3 times 3. And 3 times 3 is 9, and 9 times 3 is 27. That is the answer. 125 or 7 positive. Checking. 125 over 27.
Professor, I have a quick question.
Go ahead.
Just to make sure, so when you have the fraction, the numerator is the exponent and the denominator is the index, is what we're squaring by? Okay.
Yeah. In general, miss, suppose you have something, suppose 25 raised to the a over b is a fraction. When you translate to another language because you consider it's better for you, you copy 25, and this b is the index, and this a is the power. Okay? This idea.
Okay, got it.
Okay. This idea clarified the b or no? Suppose que no a and b because maybe it's confused. Suppose que you have 3 over 5. And then, entonces, this is the fifth root because the denominator is 5. Look, fifth root of 25 and raised to the cubic power. Unclear?
Okay. Yes.
Okay, entonces now I want to go to another topic que es similar. It's the same idea, the same, but now we have a combination. We have not only one expression, we have combinations, and using positive, using negative, using fraction, exponent. Entonces now, okay. Let me recall the rule. Recall the rule of exponent. Okay. Suppose that you have a to the fifth power times a to the third power. It's a to the a power. Where comes from this a? Was 5 plus 3. So when you multiply, and the base is the same, no? It's the supposition. It's no, see, it's another variable, no. pero si es the same, ax, y. Multiplication is addition of the exponent. Division, suppose a to the fifth again, divided by a to the third. A subtraction is a to the second. We're going from 2. 2 come from 5 minus 3. And finally, the power of the power, when you have different level of the power, suppose you have a to the second to the third. Wow, it's power of the power. Multiply is a to the 6. I come from this 6 to 23. Multiplication, add. Division, subtraction. And different level of the power, multiplication. It's the rule of the exponent. Okay? And we can apply the rule always. But I want to explain one convenience strategy. Suppose. Let's do an example 16. It's a fraction, it's x to the 1/2 divided by x to the 3/4 times x to the negative 2. And they want, using the rule of the exponent to simplify the expression, write the answer with positive exponent. Assume variable represent positive real number. Okay, they want you try to manipulate and you condense this x, we have 3, 1, 2, 3, and only one x. Okay, using the rule of. But it's totally illegal express the final answer using negative exponent. So the final answer we can write, we can express always using positive. Okay? Okay, the first thing you should do is eliminate negative exponent. Okay, this guy. This guy is negative. Ooh, not good. So the positive is nice. Therefore, stay in your place. I don't touch. However, this guy gets negative. I put in the top like a positive. You see the transformation? Reciprocal. Si es negative in the bottom, go to the top like a positive. Si es, suppose que es x to the minus 2 in the top, go to the x positive 2 in the bottom. And now you apply the rule of the exponent. It doesn't matter the order. For example, you see that this is multiplication, you add in this point. So basically it's x, so it's 1/2. Let me copy one corner of the piece of paper because I need to manipulate the fraction to say it's not countable. To say put 1/2 plus 2. No? 2 is a whole number. Any whole number you suppose that the denominator 1. The least common denominator obviously is 2. So the least common denominator between 2 and 1 is 2. 2 divided by 2 is 1 times 1 is 1. The 1/2 equal 1/2. But this is not 2, is 4, no? Because 2 divided by 1 is 2, 2 times 2. So this 2 times 2 is 4. It's 5. Okay, the numerator is 5 over 2 over. The denominator is 3 over 4. Do you follow me? So the action that we are doing is, number 1, change the negative exponent to positive. Number 2 is combine using the rule of the exponent. Not necessarily in that way. I ain't doing that way because I don't know, because I like. But you can do division first and multiplication. Oh, multiplication exactly I did. And now division. Now finally division. Division, I know get subtraction. Subtraction one more time, we have trouble with the fraction. So I copy 5 over 2 minus 3 over 4. LCD is 4. 4 divided by 2 times 5 is 10 minus 3 equal 4 divided by 4 is 1. 1 times 3 is 3. So it's 7. And the final answer is x raised to the 7 over 4. I don't know if they want you leave it like that or you change. Yeah, it's 7 over 4. Look, like that. Suppose another scenario que they want que you express the answer not like that, sino express in the radical notation. Bueno, x. Entonces now the index is 4 and the exponent is 7. and you put outside or you put inside. Either way. Oh, noise. Don't make a noise, please. Okay. Any question? Do you understand very well the manipulation or no? Yes or no?
Yes.
Okay. Okay, one more. One more. 17, no? 17 is wow. Is x raised to the 3/5 about x to the 6/5 times x to the -5. Ooh. This is similar. What should I do? Tell me.
Flip it.
Exactly. Who?
Put the bottom to the top.
But who? I don't ask you where. Who?
Oh, uh, put
Exactly.
x negative 5 to the top.
Exactly.
I'm sorry, x to the negative. Yeah.
Yeah. To convert to the 5 positive. So this is the transformation. Now, after that, what do you propose be? Well, in the other case, we are doing multiplication first. But why not? I take advantage. If the fraction have the same denominator, the 5, that will be fantastic subtracting. It's possible. I do either way. The beauty is, if you are doing well, you are doing multiplication first and division secondly, or division first and multiplication second. Good. Suppose 3/5 minus 6 or 5. Oh, but where's the disadvantage? Well, no disadvantage. You get negative exponent. Because the 5 is a no least common denominator 5, and 3 minus 6 is -3. No? So actually, this is x to the minus 3/5 times x to the 5th. Do you see that? Entonces now you say, bueno, professor, entonces you recommend me this negative exponent convert to positive. No, or yes, you can. However, in this case, you adding, because multiplication, the exponent actually is not adding, it's subtracting. No? 5 minus 3/5. Well, this is whole number, denominator 1, LCD is 5. 5 times 5, 25. Minus 3. 25 minus 3 is 22, no? The answer is x raised to the 22. See, let me see. Yes, look at that. The answer. Everyone following?
Yes, Professor.
The next page. See what page? Page. Okay, one more of the manipulation. Complicated part of is the fraction exponent. Is 18 x parenthesis x to the 4 power. No, 4 power, no. 4/3 over 3 a square b over x cubic raised to the 5/3. Okay, this is the first case, and where you see the different level of the So you have one level of the exponent, but you have x to the a and raised to the b, two levels. So you have three levels raised to the c. The answer is a is multiplication, a times b times c. It's the rule of the exponent when you have different levels. And this level is valid always, not only in the exponent. Well, actually in the radical it's the same. Square root, square root. Suppose the square root is 16. Double square root. Wow, what the hell? It's a 4 root. Because it's in this S2, it's in this S2, 2 times 2 is 4. Okay? But don't worry too much for this. Well, what should I do? Oh, nice. I like that because we have no negative exponent you need to. And you multiply this and this is x the a over 3. And remember, multiplication of fraction is super easy. You have 4 over 3 times 2. And 2 is a whole number. You consider it as 1 and you multiply top, top, bottom, bottom. A over 3. Boom. And here is 3 times 5 over 3. Oh, it's easy. 15. Look, 15. Oh, you cancel out this 3 if you want. Cancel out. Oh, suppose you don't see cancel out. You multiply 3 times 5, 15 over 3 and 5. Oh, it's 5. X to the 5th power. Finally, subtraction. Finally, subtraction. So I need to because it's division. A over 3 minus 5. LCD, again, this is LCD is 3. That's A minus 15, no? Okay, it's 3 times 5, 15. That's negative 7. It's negative 7 over 3. So far then, when you are doing that division, you get x minus 7 over 3, but it's illegal. Express it. This is correct, but it's illegal. Express the final answer using negative exponent, and you flip it one more. That is the answer. Now, let me see. Oh, yes, that one. Okay. Okay. That part of the radical, students understand very well. Traditionally, students understand very well the radical because it's easy to know. Okay, let's move on to this. Look, let me explain this problem in which you have one radical complicated and we need to simplify. This express the radical in simplified form. What means simplified form? Suppose we have 19 square root 252 x squared. Okay, you analyze separately, independent, the numerical part and the variable part. And well, in this case, you have only one variable, okay, x. In another problem, we have two variables, okay, k, q, x, y, a, b. Doesn't matter. You analyze separately, variable by variable and numerical part. So now, so you, for example, you believe, you try to find the square root of the 252 using the calculator, you are in big trouble because 252 is not a perfect square number. And give me decimal. And decimal is the approximate solution, not the actual real solution, the exact solution is exactly we need. The efficiency way to do this, you take the number and you break it down in prime factorization. You put in the calculator, I calculate 252. I know very well it's even because ending in 2. See, one number ending in even number or 0, automatically I know it's even. You divide by 2. It's 126. Again, 126 It's even. By 2 again, 63. And 63 is not even because ending in 3, but it's divisible by 3. Remember, I divide in that order. 2, 3, 5, 7, 11. Guess the order of the prime number. You start in 2. It's impossible by 2, you switch into 3. It's impossible to 3, switch into 5, and so on. In this case, yes, it's divisible by 3. Because 6 plus 3, the rule, the mnemonic divide to investigate without division, you are in the digit. 6 plus 3 is 9, and 9 belongs to the 3 table. To say it's divisible by 3, but bueno, I put in the calculator, it's 21. Nice. And 21 is 3 and 7. Cool? Okay, now, let me erase that part. Now, important. When you're working with the square root, you analyze the factor by couple. Look at the by couple. We have one couple of 2 and one couple of 3. And this couple of factor go outside like only 1, 2. I say in funny way, they get married and go outside the house. And what is the house? The square root symbol. So outside we have 2 and 3 can multiply each other, of course multiplication as a factors. So the answer is 6. Come from 6, 2 times 3. And stay single, don't get married, 7. 7 no. 7 stay inside the rack. Yeah, I did the numerical part. Okay. Now the verbal part is super easy because you know very well that this exponent is 2 invisible, no? And you divide the exponent that you have divided by 2, so 2 divided by 2 is 1. And this couple, that you can interpret like x squared, is like x times x. And it's similar to this. It's a couple of x can go outside like 1x. And you have 1x here, and no x anymore inside the rack. That is my beauty final answer. Get this. Cool?
Didn't get the last part, Professor. Can you repeat how you
Yes.
why why the X goes on the yeah.
Okay, I understand. Okay, you understand very well the factorization, yes or no?
Yes, I understand that part.
Now, in this moment, I am working with the square root. And a square root, you select the factor that is the same by couple. I see, wow, we have to do. And this 2 inside, look. This is the representation of our problem. Big square root. Instead to write 252, you write 2 times 2 times 3 times 7. And this couple of 2, actually 2 times 2 is 4. Go outside like a 1. And this couple of 3 outside like a 1, 3. And this no, because 7 is only 1, no couple. And 3 times 2 is 6. Okay, so my answer is 6 radical 7. Do you see that?
Yes, I get that part.
And the variable part is similar, but they are shortcut. It is the exponent. In this case, you have a 2, and you divide by 2, get the index of the radical. So x to the second power, but divided by 2. So the action of the square root is divided by 2, any exponent. What about, professor, if the exponent is odd number 3, 5? Well, let's see it now. But in this problem, no, nice. It's nice example in which the exponent is even number and 2 divided by 2 is 1, and this is 1x outside the radical and no x inside the radical. Cool?
No, I'm still not understanding why the x goes outside the radical instead of inside.
Explain. Don't worry. Don't worry. Look, suppose you have, I isolate the problem. So forget about numerical part. Let's focus in the verbal part. Suppose square root x to the second power, square root x to the third power, square root x to the fourth power, square root x to the fifth power. Okay, actually, the interpretation of this is x times x. Yes or no?
Yes.
Entonces now I explain que a couple of factors go outside the radical, is go outside the radical, and inside the radical we have nothing.
Okay, so whenever they pair up, then the radical goes outside. The x
Exactly.
Okay.
Exactly. This is the idea. No, but let me finish. You asked me, I try to explain. Suppose this. This is x to the cubic power. It's x times x times x. Okay, my question is, you see a couple?
Yes.
My question is then, how many x go outside the radical and how many x stay inside the radical?
One x goes outside the radical and the other one stays.
Exactly. Something like that, right? Cool.
Yes.
It's the idea. And the third problem, is 4. 1, 2, 3, 4. How many x go outside and how many x stay?
2 x's go outside.
And stay inside?
0.
0. Do you understand now? This is a shortcut.
Okay. Gotcha.
Shortcut. Suppose, not necessarily to write out, because you have, for example, this is crazy. You see, for example, you have square root x to the 25. Suppose 25. So you write 25x, professor, to see the couple. No. 1, 2, 3, 4, 5, 6. No, it's crazy. And now the efficiency way, the shortcut, is you break it down 25 from the even number close to 25, but down. But in my mind, this is x to the 24 times x to the 1, no? You know.
Yes.
And you know that the root is 2, and you divide 24 divided by 2 is 12. So x to the 12 outside and stay inside 1x.
1. Okay.
This is, I want to complicate more this, because, for example, when you have cubic root, for root, but no, let's see. Let's understand at least this example, que es number 19, now 20. No problema?
No problem. I get it now.
Now, 20. 20 is, wow, so sometimes it's confusing because give me professor negative. Remember, you have negative, it's 180. 80 what? 80K, 7, and Q8. Entonces, this negative is put here pretty useless to confuse you. But you need to be careful. You need to be aware. This negative outside is like a -1, and that's it. Entonces, you ignore, you ignore this negative, you solve the problem, and finally you put negative in the final answer. But it's okay. Keep that. So let's do it one by one. You break it down 180. And after we move into the K and we move into the Q. 180 is even, obviously, because ending at 0 is 90. 90 is also even. 40. 45 divisible by 3. I know we could adding 4 below. We take nice. 18. 15, I know. Okay. Now I see the couple. One couple of 2, I discovered one couple of 3. Therefore, I know that this represents 1, 2 outside. You put the inside the square, I put the factor outside. Any couple inside represent 1 factor outside, and you multiply it. And 2 times 3 is 6. So at least the numerical part is -6. You put a radical here because I dedicate now to the K part and the Q part. Yeah, I know, so you have 1K outside or Q, I don't know, inside, outside, but at least this is the idea. And numerical part stay inside the radical 5. Everyone follow me in the numerical part?
Yes.
Okay, so basically it's easy. You break it down, you select the couple. Any couple represent 1 number outside. You collecting any factor outside and multiplication because it's a factor, no? The only factor can stay single inside the right state. What about K7? My problem is K7. So you break it down, 7. You can do that. 1, 2, 3, 4, 5, 6, and 7. Okay, no problem. 1 couple, 3 couple. It's a K, K, KQ, right? KQ, and 1K stay. This is one possibility. What is the disadvantage? It's easy to analyze, but the disadvantage is when it's falling as a big number, so now it's too low. But the shortcut, you break it down, K7 and K6 gets the even close to 7 and K. And you divide 6 divided by invisible 2 that we have here, is 3. And this K is this K. End of story. Cool?
Yes.
Now Q. What about Q? What do you think about Q? How many Q outside and how many Q inside?
Q is gonna be 4 outside and nothing left inside.
Exactly. Is the answer. Boom, boom, boom. Let me see what is the correct answer. I suppose is that one. Okay, no bad. The radical is perfect, understandable. So you create the mechanism. Analyze quickly. Okay, let me move into 21st. The 21st is cubic. Wow, cubic. I never see cubic root. 125 x to the 4th power and y to the 5th power. Again, happen that this negative is -1. Invisible, no, it's visible. It's -1 default. And you manipulate without this and you put negative in the front. Well, 125, I know very well, is the perfect cubic number, okay, 5. But suppose I don't know. I'm taking 125, 25 is not divisible by 2, no. Not divisible by 3, no. Yes, it's divisible by 5, it's 25. And 25, 5 and 5. And you have exactly the amount of 5 that we need because we are working now with the cubic root. And cubic root need 3 factors identical. So this triple of 5 represent outside 1 factor. In this case, that was nice because 125 is perfect cubic number. The numerical part is -5 the root, okay, and you analyze y to the 4th power and x to the 4th power and y to the 5th power. Entonces now es similar, pero be careful, it's not identical. You try to find an exponent you have, que 4, what is the exponent, pero múltiplo, exact múltiplo of 4? No even. Of 3, sorry. Entonces, x cubic and x1. So you break it down mentally. 4 and 3 and 1. Why I select 3? Because it's multiple of 3. And 3 divided by 3 is 1. 1x outside and 1x stays inside. Because you have 4. Suppose you don't see clear. No problem. 1, 2, 3, and 4x. It's equivalent to x to the 4 power. But I can take 3 by 3. This represents 1x outside, and this is the x stay inside. Cool? Now, y to the 5th power. When the number is not too big, I recommend doing it that way, it's easy. Y. It's to the 5th power, no? It's 5y. And you select 3 by 3, or 1y here, outside. And stay 2y. The answer is 1y outside is this, and y is y squared. It's my answer. Clear? Another possibility is I break it down y to the 5th and y to the cubic again and y to the 2nd. And 3 divided by 3 and 1 is this. And 2 stay. See is 5. Yeah, it's this option. Cool?
Yes, cool. Got it. And the same thing goes for if the index was 4. So every pair that has 4 in it would go on the outside, basically.
Exactly. When the index is 4, good conclusion, you take 4 by 4.
Okay, got it.
And so on. 5, 5 by 5, and so on, etc. Try next. Next is easy, pero involve one extra complication. This is cubic root of minus 27, 8 to the 8th power, 3 to the 5th. Okay, as always, we analyze part by part. We focus it in the 27. 27 is perfect cubic number. I know que I did before. Cubic root negative 27 is 3, and negative 3, no? Suppose que you don't know, why don't you put in a calculator, maybe. Calculator, suppose. You take 27, know the sign, of course. Take it down, divide by 3. So we get 9, 3, 8, 3. So you have exactly the amount of 3 that we need. B. Perfect cubic number. This represents 1, 3 outside. So it's 3, but actually it's negative, right? Negative. And remember, when the index of the root is odd number and the number inside have coefficients in negative, yes, we have solution. And when the coefficient is negative, but the number, the index is even, but it's not the case. It's the only possibility that we have no solution, no real solution. Okay? The answer is minus 3. And now we analyze A to the 8, B to the 5th. Okay, either way, suppose the way that you like is 1, 2, 3, 4, 5, 6, 7, and 8, 8. And you select 3 by 3. 1, 2, and no more. This represents 1A. This represents another A. So it's A squared, que es the multiplication A times A. And inside the cubic root, we have A squared. The coincidence. Not all will happen, but it's happened. And the B is easy. B is 1, 2, 3, 4, and 5. And you select 3 by 3, 1B. B outside. And stay B squared, que es the 2B. Inside the bracket. Minus 3A square B. Es the option A. Cool. Understandable. Look, example.
Yes, definitely understandable.
Yes. Example 23 is 4 roots. Let's see what happened in 4 roots. 4 root, 4 root. And 4 roots of what? 4 roots of 81, a to the 4 power. Okay, well, you can put in a calculator, the student can know. I don't know. 81, we'll break it down. 81 is divisible by 3. It's 27. 27 is divisible by 3, again, get 9. 9 is 3 and 3. We have exactly what we need to be a perfect fourth number. So actually, we discovered root 81 is 3. And a to the 4 is 1, 2, 3, 4. Again, the exactly amount of a we need to be perfect cube, perfect 4. This represents 1a. And the 4 root, we have nothing. Everyone go outside. Nothing stay. And nothing is 1. Right? And 1 is invisible. That part is invisible. That is in my finals. 3a. One more. One more, the last one. Because after 25, 26, 27, 28, they completely did. Okay, the last one. The last one is super easy. Is cubic root again of 125 K12. K12, 12, not 13. So you memorize the cubic root. So now look. I know. 1 cubic is 1. Cubic is 8. 3 cubic is 27. Is 64. And 5 cubic is 100. 125 is perfect cubic. Break it down, obviously, is 5. Answer 5. Okay, okay. In this case, matching perfectly because 12 is divisible, perfect divided, no remainder by 3. 12 divided by 3 is 4. The situation happened, obviously, we have nothing inside the rank. So 5 k to the 4 power, like in the option. Do you see that?
Yes.
So it's enough for today, guys. Gotta go. I have another class. I need to prepare the condition for the next class. Soon I will send another email with the link connecting this video, okay?
Professor, before you go,
Uh-huh.
I sent you an email about test 3. I don't think you got it, but can you check your emails? Because I sent a request for an
Yes.
extension.
What is your name?
Grace Love.
Oh, yeah, I remember. Yeah. Just in case. I want to recheck it again.
Okay, yeah, I talked to you in class and you said it was fine for the extension, but when I sent the email, you graded it and put it.
Okay.
Yeah.
No. Don't worry too much because when I grade, I grade. Yeah, I posted the grade. You talk to
Okay.
me. I remember very well. You said you sent me.
Yeah, I sent you.
Not yet.
Yeah, I sent you an
Okay,
email
cool.
from last week.
Okay.
Okay. Thank you.
Bye. Have a nice day.
Bye.
Bye, you too.
Thank you.